Hi, welcome back to the channel. In our last lesson, we introduced the pulley system. We talked about mechanical advantage, velocity ratio, and efficiency of the pulley system. In this lesson, I'll continue with the pulley system with a worked example. I'll use this example to explain further how to solve questions relating to the pulley system. That said, let's get started. Our example says a block and tackle system with velocity ratio of 5 is used to raise a mass of 20 kg through a vertical distance of 50 centimeters. If the effort is equal to 50 newtons, determine the distance moved by the effort, the work done by the effort in lifting the load, and the loss in energy involved in operating the machine. For this particular system, we've been told the velocity ratio is 5, so that VR is equals to 5. Now, if VR is equals to 5, we've been told that the load involved in this system is 20 kg. Now, the load of 20 kg obviously is same thing in weight as 200 Newton. The load distance, we've been told the distance covered by the load is same thing as 50 centimeters. So I can have my load distance to be equals to 50 centimeters. Let's convert that to meters. In converting 50 centimeters to meters, we should have 0.5 meters. Also, we've been told that the applied effort is 50 newtons. So the effort applied to move this load is the same thing as 50 newtons. So an effort of 50 newton was applied to move a load of 200 newton. Our examiner wants us to, 1, find the distance moved by the effort. Now, to find the distance moved by the effort, let's understand first that our velocity ratio, VR, is the same thing as effort distance all over load distance, So that VR, which is 5, is the same thing as my effort distance. VR, which is 5, will be the same thing as my effort distance, let's tag it as E, over my load distance. My load distance of 50 centimeters, which will convert it to 0.5 meters. So that my effort distance E will be the same thing as 5 times 0.5 meters, which is the same thing as 2.5 meters. Now, the next thing we have to calculate is the work done by the effort. Work done by the effort, that will be the work input to the system. That's work input into the system is the same thing as effort times effort distance. So that is the same thing as effort times effort distance. Let's see our details once again. We were told effort is 50 Newton and we've calculated effort distance to be 2.5. So we're talking of 50 times 2.5. From my calculator, that's the same thing as 125 joules. That's for the second question. Then for the last question, it says we should calculate the loss in energy involved in operating the machine. Now, the loss in energy, our energy loss will come from work output minus work input. Permit my pen. I've been having challenges with this pen. Now, my work input already have been given, I've calculated it to be 1, and since we're calculating loss, expectedly, the loss will be negative. So my work output, let's solve for work output first. I have work input already. My work output is the same thing as the load times my load distance. Now, my load in this case was 200 newtons. If you can remember from our parameters, let's look at our parameters again, was 200 newtons, and the load distance was 0.5 meters. So that my load distance is 0.5 meters times 0.5 meters. Now that's equals to 200 times 0.5 meters. That's equals to 100 joules. Now, so that my loss, which is equals to the work output minus work input, had it been it again, it would have been positive. But since we're talking of a loss, it's going to be negative. That's equals to 100 minus 125 joules, which is equals to negative 25 joules. Obviously, I will express this as 20. Obviously, I will express this as 25 joules. 25 joules. With this, I hope you understand how to solve questions relating to the simple Pulley system, and in our next lesson, we'll be seeing further classes.